All right, let's look at number 5. The reaction of vanadium 2 oxide and iron 3 oxide results in the formation of vanadium 5 oxide and iron 2 oxide. And so we're not really changing the Fe's and the O's and the V's. What we're changing is the oxidation state and the charges that these two metals have in each oxide. They're wanting us to balance this chemical equation. So first we're going to have to start by changing these names into actual equation formulas. So vanadium 2 oxide, well, oxide has a -2 charge, so I just need one of each to balance out. VO. Iron 3 oxide, again, oxide is a -2. This iron is going to have a +3. Cross the charges, I'm going to end up having Fe2O3. And it's going to result in formation of vanadium 5. So it's a +5. Oxide is still a -2. Cross the charges, what are we going to get? V2O5. And lastly, iron 2 oxide. Cross the charges, we simply get FeO. Now this one's going to be very tricky. Okay? And if you get entrenched in the in one thought and you just like, oh, I'm stuck, I can't do it, you will get stuck. Okay? If you focus on the fact that you're stuck, you're just going to be sitting in your own vomit, accomplishing nothing. Now, I noticed that first off, the very first thing that's listed, the vanadium, I can put a 2 over here to make the vanadiums even out. Looking at the oxygens right now, I have 4 on this side and I have 6 on this side. Okay, let's see, 4 on this side, 6 on this side. So I need to increase the number of oxygens I have over here on the reactant side. So I'll try by putting that into a 2. So I have 2 times 3, that's 6, plus 2 here, that's 8. I still have 6 over here, so it went too far. So what I will try is, I will try to increase the number of oxygens over here to match the number over here. So let's see, what did I say? I already forgot. 8 over here, 6 over here. So let's go 3. Let's go 3. So now we have 5 from there, 3 from there. That's 8 over here, 8 oxygens over here. Now when we look at the number of irons, lastly, we have 4 and 3. Well, I hope you guys see that if I simply increase this coefficient right here, the 3, to make it so that the irons equal out, I'm going to have a problem because that's going to break my oxygen evening out. And then one simple way to try to fix this is actually just keep on making them higher. Okay, when stuck, keep on making them higher. And so what actually ends up happening is if I increase the number of irons to 6, and so I have to pump this coefficient up to 6, we find that I have now 9 oxygens plus 2 more, that's 11 oxygens. Over here I have 5 oxygens plus this 6, that's 11 oxygens. 6 irons, we still have the 2 vanadiums on each side. Again, when in doubt, try to make the numbers larger. Okay, when in doubt, try to make the numbers larger. And also, if you have an opportunity, try to pick on species, on molecules or compounds that don't have a very complex formula. It's going to be a little bit easier. I mean, messing with 2s and 3s, as you can see with this example, it actually ended up being pretty complex. If you guys tried this at home before you watch this video, you're going to see that this was probably pretty difficult for you. You did have some struggles. And again, when in doubt, try pumping the numbers up. You can always reduce them later once you figure out a ratio that balances the atoms.